Alright, we have two systems here, and it does explicitly say to use the TI-84 to graph to solve them, because this is a quadratic. We don't know how to solve these on our own yet. We need to get into chapter 2 in order to solve those. We don't even know what this looks like, but we do know what a line looks like. But if we just graph them together, we can solve it. We can use the power of the graphing calculator to do that. So let's go ahead here. Usually the only issues with these is that the zooming in and out is what we'll have to work with, right? But you want to make sure that you got rid of all your typos here, and y has to be solved for. So that's very important that you have y by itself, or else you're going to have to adjust and do that. Now I have it all entered, and I notice that my plots are off, or else you're going to get an error. So I do a zoom standard. Okay, there he is right there. There's my line. It looks like there's only one solution. Okay, perfect. So what I'm going to do is I'm going to go to second calculate, and I'm going to go to that intersection. And the intersection looks like it's, let's see, where is the, don't know where the, I actually can't see where the, from my angle I can't see where the tracing feature is. Where's X? Alright, let's start over. Oh, okay. I need to go to like -7. Okay, there he is. Okay, there we go. Enter, enter, enter. So it's 8, -4. Okay, so that is the solution. Okay, let's go do this again. We're going to clear this out. I only put 2. There's only going to be one of these on the test or the quiz, but I wanted to make sure that you guys had a couple to practice. Okay, now notice though that I can't actually enter this into the calculator just yet. So what I got to do is I have to move that x over to the other side so he becomes negative, because I need to solve for y. And now I'm going to be dividing by -1 everything. Okay. If this was an inequality, I'd flip that sign, but since it's not, I'd leave it. It's just an equal sign. So I end up with just an x plus 3. So x plus 3. All right. So now let's go ahead and graph this guy. There's 1 and 2. 2 solutions. So is it easy enough to see? Yes, that is actually 0, 3. And it is, that one looks like it could be a decimal. So that one I'm going to do a calculate. I'm going to do an intersection here. And that one I got at 0, 3. So let's move over to here. Enter, enter, enter. So yeah, so 1.5, 4.5. Okay, that's where the intersection feature is fantastic, because it'll do the decimals for you. It's not easy to see when it's not perfect. It's got to be perfect in order to use your eyes. All right, so that's that one. All right, we got a linear system here, and these guys are in standard form, not slope-intercept form. But that's good, because this is, we don't need a graph to actually solve this. All right, what we're going to do is we're going to figure out the best way to eliminate one of the variables here. You can see that this guy is a -6 and this is a +3. So if I can get away with just multiplying this line by 2, I can turn this into a +6. So that'll be perfect. So a -6y equals 18. Then I'm going to get 16x plus 6y equals 2 times, it's going to be 58. All right, 18, carry the 1. So that's that. These guys cancel out. So now I get 19x equals 76. So 76 is, if I divide that by 19, I'm going to get 4. X equals 4. So all you got to do is just pick one of these equations to plug the 4 in, and you actually already got half of your solution there. So we've got 4. We'll plug it in the first one here. So 3 times 4 is 12 minus 6y equals 18. Let's go ahead and subtract 12 from both sides. So it's 6y is 6. That's negative 6y. So y equals negative 1. Okay, so you can see it can be a short problem. Doesn't have to be a long one there. Now this one actually is going to take a couple. So this is a completely messed up. These guys are not in order. And so we want this to look like this. So when you move things from one side of the equal sign to the other, all you're doing is making it negative, okay, or positive, as long as you're adding or subtracting, okay? And that's all we're going to do here. So I'm going to put 5x minus 4y, okay, that's this equation, and I'm going to move the 7 over to the other side, okay? So in one move, I can get, well, I'm actually doing 2 moves here. I can get this set up. So this guy will move over here and he'll become a positive 9x. The negative 8y is still on the left hand side and the negative 19 is still on the right hand side. So that's good. So now if I multiply the top line by negative 2, okay, I can create that as to make that a positive 8. So there's negative 10x plus 8y equals 14. And so now we're ready to have it. Now it's just like number 17. It's ready to go. Okay, so those cancels out. Negative x, and that's negative 5. So it looks like x equals 5. So what you could do is take a gander at your choices, and if your x coordinate is 5, and there's only 1, then you're all set. But since I don't have that yet, why not plug it into the second equation there? So negative 8y equals negative 19 minus 9 times 5. So what is that? That is going to be negative 19 minus 45. Okay, so 45 plus 19 is going to be 64, but it's definitely going to be negative. So when I divide by negative 8, we're going to get a positive 8. So our answer, our intersection is 5, 8. Alright, number 19, looks like actually this guy, looks like the numbers are going to get kind of large here, but that is okay. That is definitely okay. Why don't I multiply this guy by 8 and this guy by 10? Okay, and that way they'll actually become 80, but notice how I have to I multiply both lines, okay? And then, oh, you know what though? Nope. Actually, 8 and 10 will both go into 40. I don't actually have to go all the way to 80. So if I multiply the top line by 5, okay, that'll be 40x minus 35y. And then this will be 40, carry the 4, negative 140. And then this will become 40x. Then this will become negative 20. And then that will become negative 80. This becomes negative 55y as those cancel out. And now I've got negative 220. So what is 220 divided by 55? I guess it's 4. Yes, so y is 4. Good, there's half my answer. The y coordinate is 4. So let's go back up to the top there. Negative 8x minus 7 times 4 equals negative 28. Well, that is negative 28, so when I add, that's 0. So when negative 8x equals 0, x can only be 0. So it looks like it would have hit the x-axis right there at 0, 4.